Okay, we're back here. I think we're still in the process of translating the type neural rate into CUDA. So right now, I think I got matrix derivatives. Yeah, that's the derivatives function, which is the derivative of the weight is the deltas times the. Oh wait, am I sure I got this right? Oh, the deltas times the outputs. Yeah, the deltas times the outputs. You have to remember that derivatives is outputs here because for some reason I think I should call source outputs and result deltas, but if it's not clear enough, you should already know how to do it. We're gonna take care of it when it comes time to do the neural network translation. Actually, we took care of it already. But anyway, let's just continue translations, and then we'll deal with everything else later. Okay, matrix transfer functions, transfer forward. Another one that's somewhat more difficult than usual. Let's copy this here, and copy this just to make sure that we got it. Oh, wait. Am I missing something? Oh, transfer reverse. I just copied too much. I'll do that later. Okay. Now we need to translate this. I'm not going to use a specific function here. I'm just going to put it inside the kernel. Okay, step one, copy the kernel. Copy the kernel code. And global neural unit transfer forward. Kernel transfer forward. What? I'm going to need that later. Okay, kernel transfer forward. Kernel rate transfer forward. I'm never sure what to call those, but the name's not that important. It's only going to be used in one single place anyway. So, okay, value CUDA neural unit results source. Oh, now you have to make sure result source transfer. Okay, result source transfer CUDA neural unit result source length and transfer. Let's copy everything. Okay, unsigned length and transfer. Okay, we're doing everything one step at a time here. That's just the interface. Now it gets more difficult. Okay, now we need to copy all this and put it here. But there's a lot here that doesn't work. A lot that doesn't work. So copy this part and transfer it up here. Now let's start translating stuff. Okay, if I less than length, that doesn't require anything. Okay, now switch transfer. Case type no RELU, CUDA no RELU. Oh, this is gonna be problematic. This is gonna be a huge problem later, but we'll fix it. Okay, copy the device functions. No, there we. Oh, what am I doing? Oh, I got lost here. Okay, copy this. I paused and I got lost. Okay, now we need to translate all this into device GPU functions. So it's double underscore device. This is what you use to make it into a GPU function. I need to reorganize everything here. I'm just typing the code, but I'm not taking care of putting everything in the right places. Device. The problem with CUDA is that everything has to be compiled inside a single file. That's why I can't organize everything. Okay, we just rename all this function device, and now we can use them. Wait a minute, what? External C double RELU function. Oh, okay. We may have a problem somewhere. Somehow it doesn't like it. Does not match function type. Ooh, that's a problem. Let's change the names. CUDA RELU. CUDA RELU function. Let's change the names because it seems to be complaining about something being duplicated. That's just a compiler specific thing. You don't need to worry about it. SIGMOID function, CUDA SIGMOID. This function right here, they already exist inside CUDA, so it really doesn't matter. CUDA has its own copies. TANH derivative, and we're done. Okay, let's copy this right here. CUDA RELU and CUDA RELU. Oh, wait. That's why it doesn't work. It's the return. It's actually not necessary to call it CUDA, but we already did it, so it doesn't matter. Okay, source. You have to copy all of this here. Source.i. Source.i result equals. Result.i equals not transfer forward. Okay. We have to copy it up here. Okay, result.i equals copy equals RELU function source. Okay, wasn't so hard. So let's just get rid of all this. As a default, source equals 0, result equals 0. Oh wait, no, default. Do I need a default? I don't need a default, doesn't matter. Just return. Okay. So that was relatively easy. We just have to make the device functions and then call the specific function. Eventually, I'm going to create a softmax function, but for now, it doesn't really matter. Okay. Now copy CUDA neural. No, CUDA neural. Oh wait, TensorFlow. Oh. Oh wait, that's something else. That's something else. Transfer forward. Okay. That's something else. Okay, CUDA neural array. Transfer forward. Oh, did I copy it? I'm just pressing the wrong buttons here. CUDA neural array. CUDA neural array. Not quite sure if it's going to work. CUDA neural array. And source result transfer. We need transfer for I equals 0 for if result not equals source. And now we just need the kernel. Just copy everything here and then adapt it. Now for the name, CUDA or let's just make sure we stay consistent. CUDA array transfer forward. Kernel array transfer forward. Just change the name. Kernel array transfer forward. We got results, source, length, and transfer. Okay. Let's get rid of this. And that means everything is copied correctly. Oh no, wait, result array. Oh, it is. Okay, so the for loop is just replaced down here. And we're done. Yeah, that wasn't so hard. Okay. We're gonna have to move this somewhere else, but for now we're good. Okay, now transfer reverse. It should be the same thing. Oh, where are we? Why am I doing all the way up here? Convolution. Transfer reverse. It's slightly different. Transfer forward and transfer reverse. Everything's the same except we. Oh no, there's something really different. Let's not forget this. There's something really different going on here. We're just gonna copy this part right here. Actually, we need both because there's a slight difference we need to take care of. Transfer forward and now transfer reverse. Copy this up here just so we know where we are. And copy this part right here so we can adapt it. We don't need to reinvent the wheel here. Okay, where are we doing? CUDA transfer RELU. Actually, we just have to RELU derivative. Just copy the name derivative. Everything else is the same. Is there a function? Just rename derivative. But there's one more problem that we have to deal with right here. CUDA transfer reverse. Let's call it reverse. No, reverse. No. Ah. Okay. If I call length switch transfer reverse. Okay, so this part right here is mostly correct. So we don't have to worry about it. Now the problem comes down here. So we replace source, CUDA type, sigmoid derivative. Why does it say sigmoid derivative? Oh, because you changed it. I completely forgot. Okay. So it's source times a slight change, source equals source, not source derivative, just source times that's no source equals result times sigma derivative outputs, not transfer outputs. So let's just add outputs to the list. Now we need to expand this to include the outputs, because that's how the derivatives works. You have to multiply the derivative by the output in order to do backpropagation. Output. Is it outputs or outputs? Change the name right here. Outputs. Okay. Let's copy the actual body of the function and start making modifications. Okay, result array source outputs. Okay, we need that. Okay, just copy everything here. Now we just need the top part, the first line. Everything else is the same. Outputs, result.array length, identical source.array length, dim blocks. Let's change the name, kernel array transfer reverse, and then add outputs to the list. Oh, there's something else I forgot. Oh, I forgot it in both places. Okay, if result.array length not equals source.array length, or result.array length not equal outputs.array length, they have to be the same. Not equal outputs.array length and result. Let's copy this right here because that's a mistake that. Wait, that's where am I? I remember here, but I didn't remember over here. Okay. I'm gonna have to clean that up later. When I'm done with this, I'm gonna clean that up. Whoa. I'm in the wrong place. I'm in the wrong place. I copied in the wrong place. Okay. Everything's the same except down here, kernel, and then we need to add outputs. No, we already added it. Kernel transfer reverse, outputs, and delete. Now make sure we didn't miss anything. Get rid of that. And get rid of that. There's a lot of cleanup left to do, but for the most part, we should be good. We did the derivative of the output. Let me just make sure I didn't miss something because it really doesn't feel right. TANH derivative. No, down here. It's the derivative of the outputs times the deltas multiplied by the deltas. Okay, we need to take the derivative of the output times the deltas. That's how you do backpropagation. Okay, whether it's convolution or fully connected, it's all the same thing. If you want to make everything go faster, just take this function right here and just merge it as part of the convolution. But I just prefer to put it as a separate function. Not because, even though it's slower, just because it's easier to read, and if there's a mistake, it's easier to trace down. But it's really not necessary to do it that way. Okay, CUDA derivative function, CUDA TANH derivative, everything is the same. Okay. Oh wait. That's some cosmetic stuff here. Okay, everything should be the same. Let me just compile, make sure I didn't make any typos, but okay, the code compiles, which means it's working as well as it's going to. Okay, next. CUDA neural array, now we get update momentum. Oh wait, momentum is slightly different from the others. Okay, now update momentum. Okay, we need the kernel. Okay, kernel array update momentum, which needs, let's keep the names, weights, vectors, and deltas. They're all the same size, so it really doesn't matter. Weights, vectors, and deltas. Okay. Change the name to, no, actually we don't need that. Okay. We just need to copy this part right here and into this. Now just replace the parts. Oh, wait, learning rate and momentum. I need that. Deltas, learning rate, momentum. We're not done. We are not done. Do I put it inside or outside? Yeah, inside's good. CUDA neural unit, learning rate, momentum. Okay, let's make sure we don't make any mistakes here. I'm not sure if I should put the order of the parameters doesn't make any difference, but I just prefer to be consistent, or try to be. Okay, weight vectors, deltas, learning rate, momentum, and length as last one. If length equal to 0, vectors equal vectors dot I times momentum plus 1 minus momentum times learning rate times deltas. Okay, weights dot I equal weights dot I plus vectors dot I. Okay, so far so good. Vectors, deltas. Okay, let's just change everything from CUDA, from type to CUDA. Global type null, CUDA null. Okay, make sure I didn't miss anything. No. Type to CUDA one. Let's do everything just one step at a time. Make sure you don't make any mistakes. Okay, we don't need that. If weights, not if vectors, if everything's the same size, we're good. And now let's just transfer the kernel call. Okay, first the name, kernel array update momentum. Oh, wait, no, what is it doing? Kernel array update momentum. Oh, just copy. Okay. Oh, did I forget something up here? TensorFlow result. No, I didn't forget anything out here. Okay. Now weights dot array length. Copy this. Oh, we don't want to mess that up. Copy this right here, and now we need. Let's just move everything down here. Okay. Weights, vectors, deltas. Now weights. Now weights, vectors, deltas, and move down here. Deltas, learning rate, momentum. Let's just copy. Learning rate and momentum as parameters. That comes before length or after length? Before length. Momentum. Weights, vectors, deltas, learning rate, momentum, result of array length. Everything should be the same. Get rid of that. Okay, everything's in order. All right, get rid of this. Just make sure we didn't miss anything. Just put that up here. Oh, it doesn't matter. To put it down here. The compiler is not gonna know the difference. Result of array length. Okay, we've done momentum. Next. Okay, double check, make sure everything's right. Yeah. Although maybe learning rate should go down here, but I put it up here because otherwise vector is just gonna get way too big. Okay, kernel reverse, no. Okay, next. Next. Add a grad. It's more difficult, but the difficulty is not something we need to worry about here. Just copy everything. Okay. Now we take all this code and copy it. I'm not sure if that's what we should be doing ahead of everything, but oh, wait. We need all this also. Cut. And we need all this. I need the I, epsilon. Oh, wait. I'm gonna fix this, but first, let's just fix this. Okay, what do we need? The parameters. Update moment. No. Oh, we copied too many things. Update momentum, kernel array, update momentum, weights, vectors, deltas. We copied too many things. Do we need this part? If I don't copy this now, I'm going to confuse myself. So let's just copy this now. Update, add a grad. Weights, vectors, gammas. Let's just add after that, gammas. Vectors, gammas. And gammas, deltas, learning rate, momentum. Okay, same thing. No, we replace that with CUDA, just so I don't confuse myself. No, CUDA. Okay. Now, everything here has been copied. Now let's just modify everything one step at a time. CUDA only M2. Now it conserve. Oh wait, now we still need the gammas. Oh wait, let's change the name. Let's not confuse ourselves here. Gammas. Make sure everything's the right order. Gammas. Data equals gamma data times momentum 2 times deltas dot I squared, delta dot I squared, gradient, the adaptive gradients. Whoa, I did not change the name. Add a grad. I thought I changed the name, but I didn't. I don't know what I did. I add a grad. Okay. Oh wait, I didn't mean a mistake here. Gammas. Oh, don't get this wrong. Make sure I didn't mess up. Okay, gammas. Okay, equals square root of gammas.array data times plus epsilon. Okay, vectors. Okay, vectors equals vectors.I 1 minus momentum grad as in the adaptive learning rate times deltas, and now weights.I equals weights.I plus vectors.I. Okay, did we miss anything? Everything looks to be in order. Okay, add a grad. Okay, now let's modify this part, make sure we didn't miss anything. And again, something we missed. Well, it's not important, but it could be. So let's just make sure you take care of it. I'm really gonna have to clean that up at some point, but I'll just start doing it now. Gammas. We're gonna have to mess this up. Make sure that everything is the same size. Return 0. Okay, that's just a cosmetic thing, but that's not important. We're gonna clean everything up later, just to make sure. Okay, weights.array length. Everything's the same. Gammas. Forget. Let's not forget. And why am I calling? Oh, mistakes. Wait. Dot array length. Okay, change the name to weights. The compiler would have caught it anyway, but just make sure we don't make the mistake here. Gammas. Okay, make sure everything is in the right order. Okay, everything's the same. Everything's in the right order. Weights.array length. Make sure we didn't make the mistake here. Weights.array length. Is it weights? Yeah, weights.array length. And we're done. Okay, almost there. Weights.array length. And now for the last one. We're just gonna copy everything down here. Now we'll change everything to Adam. Update Adam. Just copy everything here, just so we don't mess anything. The parameters are mostly the same, so we don't have to change much. Okay. Adam is weights, vectors, gammas, deltas. Everything's the same. So let's just copy the parameters and change to CUDA. CUDA neural. Just do it manually instead of using the automatic search feature, but just to make sure we see everything going on, just so we miss anything. Okay. How many is that? Yeah, that's 9. Maybe epsilon's so small. It's supposed to be 8. Yeah, 1 OE8. It's not a big difference, but just to be consistent. VT. Okay, now let's copy all of this here. This is the actual work. Huh? Whatever. Let's just copy all of this here. Whoa. I need to make sure I know which one's doing what. Oh, wait. Otherwise, I'm going to confuse myself. Update Adam. Let's just copy this right now, because otherwise we're just going to confuse ourselves. Adam. All the parameters are the same, so we don't need to worry about that. Copy and paste. Copy and paste. And gammas dot I, delta squared, and delta squared. Okay, vectors are I equals vectors are data momentum vectors. Okay, learning rate square root a plus epsilon. Go weights. Whoa, wait a minute. Ah, vectors is already taken care of. Okay, why the difference here? Ah, that's to adapt everything, but it doesn't matter. Everything's the same, more or less, and it's good. Update Adam. Oh, wait. Made a mistake again. It's grad. Forgot to copy the name. I mean, like I said, compiler would have caught it, but let's make sure we do it visually, just so we don't mess up anything up. Okay, update Adam. Just call the kernel function update Adam. Gammas Gamma times time. I'm just visually verifying, making sure I didn't miss anything. Okay. Okay, update Adam so far looks good. So far. Update adequate. Let's see if there's anything more to copy. No node array. And that's it. Next thing left to do is just to verify that everything works. Because maybe it won't. Okay. Now I'm going to compile and make a test to make sure I copied everything correctly. I'll be back later. I don't want to have to do this live. That's going to take too long. Okay. I've made a lot of cosmetic changes. Nothing. I haven't changed anything much, but just to make everything look cleaner. First of all, everything that as in type shape here, everything that referred to the type library, I've just removed completely. This is just to make sure that the CUDA part and the type library part are completely separate. For example, the shape. I've just made its own version of CUDA shape, and then copy all the CUDA function, all the shape functions into their own CUDA versions. And yeah, I just copy the functions because I don't want to have to. I don't have to link everything. And then everything here, the link, I just put everything here. And then the function names. The function names are very long, but I want to be explicit when it comes to CUDA. So index map 2D copy instead of an index map copy 2D. Just change the function names and then change everything to say that the index map is in two dimension. And then we have all well, that's not all the functions we're gonna need. Actually, there's a lot more extra functions, but these are all the ones I've copied for now. And that's pretty much as far as CUDA functions go. But the next step right now is to go into the previous neural network library and then basically convert everything I've done for neural network into work with CUDA. And that part also is going to take a long time, like the build network. Instead of type neural network create. Now I need to decide what I'm going to do. Do I create a type neural? Do I just create just refactor everything to use CUDA, or do I just create two different versions of neural network, or do I just rename type neural network to use CPU? No, I'm just going to rename everything to use into CUDA names, but use CPU version just to make the code obvious, just in case you want to read the two different types of code. But everything that I use for neural network, I'm going to rename to use CUDA, and then just have two different versions of the library, so I can switch back and forth between them. I'm just going to do that now. Just pause and do that. Okay, to be clear, we cannot just replace everything, but we're going to replace most of everything that uses CUDA neural array with to type neural array to CUDA neural array. And then type index map needs to use CUDA index map, but we can't just use it directly. There's a lot of very careful stuff you have to do here. I'm just going to replace everything CUDA neural array, but oh, this is going to be very painful. But anyway, I have to go to every function one by one, make sure I didn't miss anything. If there's anything important, I'll start over, but I'm just going to pause it because that's going to take hours. See you in a few hours. Okay, right here. While doing the modifications, we did bias, the basic layer, we just change everything to CUDA. The bias layer, we just change everything to CUDA versions, CUDA neural unit, and all the CUDA functions is just the same thing. But here we have a problem. Okay, now we need to fix this. Okay, first we create the arrays. We just call CUDA neural array. Since we're not touching anything inside the arrays. We're not touching the data, we're not doing anything. So this is fine. Okay, fill random, we're just calling the functions. Type shape assign, we're using type shape here, so it really doesn't matter. But here, we need to create an index map. We cannot create an index map directly. That's impossible. And we can't use the index map layer 1 here because that's also going to create problems. So we need two new index maps here. Type shape, type index map. No, CUDA. Oh, no, type index map, not CUDA index map. Type index map. This is to create the map inside in the CPU version before copying it into the GPU version. Index map 1 and also index map 2. It's gonna be tedious, but we have to do it that way, otherwise we're in trouble. Index map, let's copy this down here so we don't forget. Okay, index map 1. This is cosmetic thing, but we have to make sure we get this right. Index map 2. Okay, that's step 1. Step 2. Go back here and just copy this. Did I remember to? I didn't say that before. Index map. I made a modification here. Go to definition. Instead of copying index map, a type index map, I don't want to have to. I don't have to refer to the original index map, so I just create CUDA index map by itself, and then just call the new index map using the width, height, and the data, because it doesn't need to know that there's a different kind of index map. Just call the width, height, and the data, and then just allocate it the same way you would allocate an image. The width, the height, and data length, and then just create a new one. Make sure we get everything right, data length, and then copy the data inside the new index map. Okay, that part's very simple. Okay, index map create copy. Let's use that one, and then have it down here. So we have to do everything in 2 steps. Find the index map 1, index map 1 dot index width, index map 1 dot index height, not dot index height, index map 1 dot index data. What am I doing? Okay. No, make sure you get this right. Data. Bit tedious, but we have to do it that way. Otherwise, CUDA is just very fickle. Having to operate on 2 different computers at the same time is that's the difficult part. You constantly have to keep in mind 2 different programs. Okay. So, whoa, what the hell? No suitable function index map. Oh, CUDA index map to CUDA index map point. Oh, we need to use a pointer. Like I said, we have to keep in mind 2 completely different programs at the same time. That can get really tedious. Okay, so far I don't think I left anything. So we just have to change the function names. So there's really nothing here to see. So I'm just going, and this part right here, we're gonna have to change later. That's just really ugly. Right now, I'm gonna worry about it. I have to put in something where I get to select between the 3 different update methods, but that's a personal choice thing. It's not really that important in the code. So we're just gonna do everything cosmetic offline. So see you later. Oh, and one more thing I forgot to include. We need to destroy the index maps. Just copy this right here. We create them, we copy them, and then we destroy them. Again, that's just tedious. Type. And also we need to keep track of which one are we using. Are we using the CUDA one or the CPU one? Again, having to program 2 different computers at the same time, both the CPU and the GPU, is really the tedious part. Okay, so this is done. Now we're gonna do something else. We're just gonna continue. Wait, we forgot something. No, we didn't forget anything. But there's one more problem: pooling. And do not layer create assign type create index map scale to D. Okay, that's the pooling part. It's the same thing. It's the same thing as the convolution part. we have to create the index map and then copy it, and then copy it and then destroy it. I'm just going to do that offline. Just know that it's the same as this one. Create, copy, and destroy. Same thing for pooling, same thing for scaling. Okay, I've been running the code and it seems to be working. Here's what I did, because it took a little while. I just changed everything from CUDA, from type neural network to CUDA neural network, and it took several hours to make sure I got everything right. And then a test function, I wrote a test function here. That's to create the neural network. It's kind of ugly, but I'm gonna have to fix that because I really don't like the way it looks here. I'm gonna have to fix it, but the priority is just to make sure that it works. And apparently it does work. There's 100. I added something to count how long you go per frame, but it does eventually. It's an autoencoder. It works. It's entirely possible that I made some kind of mistake I haven't seen yet, but so far it seems to work. All the code is written. This is the test function right here to run the network. We just go to get augmented is for when I decide to do the image augmentation, but right now I'm not doing anything for that. And then we just feed forward, backpropagate, get output error, and then draw everything. And also we load everything into in an array of networks, into an array of neural arrays into a data set, just to make sure I don't forget anything. Right now everything is just quick and dirty. This is not the right way to do it, but so far we're just doing from scratch. So far everything seems to work. I'm going to continue adding functions and testing everything just to make sure I didn't miss anything important, but so far everything was good. And let's just look. The error keeps going down. Like I said, it's possible I missed something, but so far it's not looking at it like it at all. So far it's working just perfectly. Well as it could. Anyway, I'm just going to keep checking, but that's it for tonight.